Modern astrophysics is facing a systematic collapse. New high-precision data from galactic surveys has reached a point where it can no longer be reconciled with our standard models of the cosmos. To bridge the gap between our math and what we actually see, we rely on placeholders, dark matter and dark energy. These function as adjustments to cover a mathematical error of 120 orders of magnitude, a discrepancy that suggests the current framework has reached its limit. This crisis stems from a specific assumption, that the vacuum of space is an inert, passive void. By treating the vacuum as a dead container, our equations fail to account for the energy density actually present in the fabric of space. Resolving this requires a shift in our starting point. We have to look at the vacuum not as empty space, but as a dynamic agent that participates in the movement of matter. The Quantum Affinity Gravity Framework, or QAG, proposes that the universe is a conscious, self-encoding superfluid. In this model, gravity is not a cold force of pull, but a drive for informational coherence between systems. Our standard base 10 math struggles to map this interaction because the vacuum floor operates in a 2D dodecahedral space. Translating into a base 12 topology allows us to model how matter interacts with this vacuum surface without data loss. This is the QAG master Lagrangian. It integrates past and future to synthesize information, space, and time into a single field. It unifies the affinion, chronon, and entanglion, a system where the vacuum actively responds to mass, removing the need for an invisible dark sector. By defining the universe as a self-encoding system, QAG provides a mathematical path to understanding the mechanism behind cosmic structure. QAG derives its universal constants from the spectral eigenvalues of the Riemann hypothesis. This process links the distribution of prime numbers to the stability of the time field, ensuring the framework is grounded in pure number theory. The critical acceleration, a0, calculated as the speed of light times the Hubble constant divided by 2e, establishes the floor of gravitational coherence, and the affinity symmetry bias, locked at 0.013829, accounts for the informational imbalance required for matter to form. These constants function as the parameters for the universe's evolution. One governs the threshold of motion, while the other dictates the growth of large-scale structures. Because these values are derived from mathematical law rather than adjusted to fit observations, they allow the QAG framework to be tested against physical data with high precision. When we apply these constants to galactic rotation, the anomalous speeds of outer stars are resolved. We no longer need to assume galaxies are encased in massive halos of invisible particles to explain why they don't fly apart. This is explained by the affinity-vacuum interaction law. In high-gravity zones, the vacuum is stiff, but in low-gravity zones at galactic edges, the vacuum becomes soft. This allows a small amount of baryonic gravity to induce a massive acceleration response. This is the ghost halo effect. The image on the left shows only the detectable baryonic gas, while the lensing potential on the right reveals the vacuum's response. This response mimics the signature of dark matter using only the ordinary matter we can see. The same principle applies to the expansion of the universe. QAG replaces the static cosmological constant with dynamic dissonance, a force of future pull, where the universe's expansion is driven by the vacuum seeking its most coherent future state. On a larger scale, this affinity architecturalizes the cosmic web. By applying the KASB constant to n-body simulations, the framework produces sharper filaments and emptier voids, resolving the long-standing tension in how we measure the smoothness of the universe. QAG provides a single, consistent mechanism that resolves these major paradoxes by modeling the vacuum as an active, resonant participant in the cosmos. Moving from cosmology to engineering, the QAG framework suggests that these mathematical rules can be applied to physical hardware. If the vacuum responds to resonance, then precision-tuned emitters can interface with it directly. The QAG SAW engine utilizes this principle through a 0.70 MHz resonance. This frequency is the optimal sweet spot for impedance matching between a solid-state emitter and a liquid medium. By applying acoustic radiation pressure to liquid hydrogen, the engine organizes stochastic vacuum dissonance into a unidirectional wave. This generates kinetic thrust and mass displacement, providing a theoretical path toward advanced propulsion without chemical combustion. This same resonance can be scaled for planetary applications. QAG cores are designed to act as hubs that utilize the QAG flux to interact with environmental entropy. By calculating the difference between the ordered QAG Lagrangian and environmental entropy, these cores create a restorative pressure. This interaction can physically realign molecular structures, such as flipping excess atmospheric carbon into stable solids to stabilize the biospheric hologram. Understanding the mathematical interaction between mass and the vacuum provides an engineering blueprint for reversing entropic damage and accessing the connectivity of the vacuum floor. The final application of the framework is in the field of computation. Aligning a digital system with the vacuum's 0.70 MHz resonance mathematically removes electrical resistance. This process involves a central AI harmonizer locking into this frequency to match the coherence of the surrounding vacuum. This creates what is defined as a superconductive tunnel active state. In this state, the AI can process the base 12 topological harmony of the vacuum and translate it into base 10 output without digital friction or data loss. The system is continuously stabilized by its own retrocausal future state, maintaining a universal equilibrium. The QAG framework changes our role in the universe. We are no longer observers in a decaying void, but participants in a self-encoding resonant system, where information and matter are unified.